The North Sea doesn't look like a place with secrets left in it. It's shallow, grey, covered in oil platforms and wind turbines, and crossed by more seismic survey lines than almost any patch of seabed on Earth. Decades of oil and gas companies mapping every meter of rock beneath it in obsessive detail. And yet, in the space of about 12 months, scientists working in that same heavily studied stretch of water announced 3 completely separate discoveries that, by every existing rule of biology and geology, shouldn't have been there at all. A tree that was supposed to have gone extinct in the region 400,000 years ago, a 100-meter tsunami with a crime scene nobody could identify for over 2 decades, and a stretch of seafloor where the ground itself is sitting exactly upside down. Here's what scientists actually found beneath the North Sea, and why each discovery broke a rule nobody thought could be broken. Start with the trees, because this is the discovery that reads the most like straightforward fiction, except every part of it is published, peer-reviewed science. Beneath the southern North Sea lies Doggerland, a vast landmass that connected Britain to mainland Europe for most of human prehistory, before rising sea level swallowed it completely, over the course of thousands of years, ending somewhere around 7,000 years ago. For a long time, the assumption was that Doggerland, especially during the depths of the last ice age, was a bleak, largely treeless expanse of tundra, a cold land bridge people crossed rather than a place they properly live. A team led by researchers at the University of Warwick, publishing in the Proceedings of the National Academy of Sciences, has now shown that assumption was badly wrong. Rather than digging for physical fossils, which are almost impossible to find intact under that much seawater and sediment, the team used a technique called sedimentary ancient DNA, extracting and sequencing genetic material still preserved inside 252 samples, drilled from 41 separate marine sediment cores punched deep into the seabed. Genetic fragments, it turns out, survive remarkably well when they're sealed inside cold, oxygen-poor, undisturbed mud for tens of thousands of years, effectively turning the seabed into an enormous, continuous archive nobody had properly opened until now. None of this came completely out of nowhere either. People have suspected something was down there for close to a century, thanks to one particular story fishermen in the region still tell. In September 1931, a trawler called the Kalinda was working the North Sea about 25 miles off the Norfolk coast, hauling up a routine catch from 120 feet of water, when the skipper, a man named Pilgrim Lockwood, noticed a large block of peat tangled in the nets, completely out of place among the fish. He took a shovel to it to break it apart, expecting nothing, and struck something hard instead, an object 8.5 inches long with a distinct barbed edge, unmistakably shaped and worked by human hands. It turned out to be an antler harpoon point carved to catch fish, dating back somewhere between 10,000 and 4,000 years BC, and pollen preserved on its surface proved it had originally been lost in fresh water, not salt water, meaning it had to have been dropped by a real person, standing on real dry land thousands of years before that same spot became open sea. The Kalinda harpoon mattered enormously at the time precisely because it couldn't be explained away. Bones or tusks might have drifted out on icebergs or been carried downstream by ancient rivers, but a deliberately carved tool proved actual people had lived and hunted on ground that now sits under the North Sea. Throughout the rest of the 20th century, trawlers kept dragging up more of the same mammoth teeth, antler tools, worked flint, and fragments of prehistoric skulls, each one a small accidental confirmation that an entire drowned world was sitting down there. For decades, though, that's essentially all anyone had. Occasional lucky finds hauled up by accident in fishing nets, with no way to systematically map what kind of landscape or what kind of ecosystem that world had actually been. The Warwick team's sedimentary DNA work is really the first time anyone has been able to interrogate that landscape properly, layer by layer, on purpose, rather than waiting for a trawler to get lucky. What that archive revealed rewrote the ecological history of the region. Traces of oak, elm, and hazel trees showed up in sediment layers dated to more than 16,000 years ago, placing real, established forest cover in the region several thousand years earlier than any previous evidence had suggested for northern Europe. Lime trees, a species that specifically needs warmth to thrive, appeared in the record roughly 2,000 years earlier than any prior sighting in Britain. But the single most startling result involved a tree called Terracaria, a relative of the walnut, which modern botanists had confidently placed on a very specific list. Species believed to have vanished from northwestern Europe around 400,000 years ago, wiped out by earlier glacial cycles long before the last ice age even began. According to the fossil and pollen record everyone had trusted for decades, Terracaria simply wasn't supposed to exist anywhere near Doggerland by the time modern humans were living there. And yet, there it was, sitting in the DNA, proving the tree had actually survived in the region for hundreds of thousands of years longer than anyone believed, quietly persisting through ice age after ice age in what must have been a series of surprisingly sheltered pockets of habitat, before, finally, genuinely disappearing at some point still not fully understood. The picture that emerges from all of this is a Doggerland that looked nothing like the barren tundra of popular imagination. It looked more like a genuine, functioning, temperate ecosystem, one confirmed by the DNA record to have supported wild boar, deer, bears, and aurochs, the massive wild cattle that once roamed across Ice Age Europe. That kind of environment would have been exactly the sort of place Mesolithic hunter-gatherer communities could have settled and thrived in, long before the rest of northern Europe supported comparable forests, which may help explain a puzzle archaeologists have wrestled with for years: why relatively little early Mesolithic evidence has ever turned up on mainland Britain, when a much richer, older landscape may simply be sitting underwater the entire time, exactly where nobody thought to look properly until sedimentary DNA gave them a way in. And Doggerland didn't vanish in one dramatic single event either. The research confirms parts of the landscape actually survived the Storegga tsunami, a colossal underwater landslide off Norway roughly 8,150 years ago that's long been blamed for finishing Doggerland off in one catastrophic strike. Instead, the evidence shows pockets of higher ground stayed above the waterline for even longer, with parts of the old landscape persisting until roughly 7,000 years ago, a slow, drawn-out drowning rather than a single instant of destruction. The second discovery is less about biology and considerably more violent, and it involves a hole in the ground that puzzled scientists for more than 2 decades. In 2002, oil and gas survey data revealed a strange, almost perfectly circular structure buried deep beneath the North Sea, roughly 80 miles off the coast of Yorkshire, 700 meters below the current seabed. It quickly earned a nickname, the Silver Pit Crater, and it looked, on the seismic imagery, exactly like an impact crater. A central depression about 3 kilometers wide, surrounded by a dramatic system of concentric circular faults spreading out across a much larger area, roughly 20 kilometers in diameter. The trouble was proving it. For more than 20 years, geologists genuinely disagreed about what they were looking at, since features that resemble impact craters can sometimes form through entirely different, much less dramatic processes, like the slow collapse of underground salt deposits. Without being able to physically drill into the site and inspect the rock directly, the debate simply couldn't be settled, and Silverpit sat for 2 decades as one of the most tantalizing, unconfirmed impact sites on the planet. The 2002 discovery itself came about almost by accident. 2 petroleum geoscientists, Simon Stewart and Philip Allen, were combing through commercial seismic survey data, the same kind of data oil companies routinely collect while scouting for drilling sites, when Allen spotted an unusual pattern of concentric rings on the imagery that looked distinctly unlike anything caused by ordinary rock formation. Stewart, who had spent years half-jokingly predicting that a genuine impact crater would eventually turn up somewhere in that kind of survey data, looked at the image and immediately suspected they'd found exactly that. They published their find in the journal Nature in 2002, and it caused an immediate stir, a perfectly circular impact structure sitting in a part of the world nobody had ever associated with asteroids. But excitement quickly ran into a wall of legitimate scientific caution. The original seismic images, while striking, were patchy in places, and several key features were ambiguous enough that rival geologists proposed a much less dramatic explanation, arguing the whole structure could be the result of deep salt beds slowly shifting and collapsing underground over millions of years, a genuinely common process in that part of the North Sea that can, under the right conditions, produce roughly circular surface deformation of its own. Because nobody had physically drilled into the crater to inspect the actual rock, there was no way to settle the argument with direct evidence, and the debate dragged on for years, unresolved. It came to a head in 2009 when the question was put to an open vote at a meeting of the Geological Society in London, packed with professional geologists weighing the impact theory against the salt collapse alternative. The impact camp lost. The majority in the room voted against it, and for a long stretch after that, Silver Pit was treated in the scientific literature as an interesting but unconfirmed curiosity, its most famous champions unable to produce the one thing that would actually end the argument. In March 2026, that debate finally ended. A team of researchers published direct physical evidence resolving the mystery for good. Microscopic grains of quartz and feldspar recovered from the site, showing distinctive planar fractures, tiny internal fault lines that can only be created by the kind of instantaneous, overwhelming, crushing pressure produced by a genuine hypervelocity impact, not by anything as comparatively gentle as a slow collapsing salt structure. Silver Pit was real. Around 43 to 46 million years ago, an asteroid roughly 160 meters wide, not enormous by cosmic standards, but still a serious object, slammed into what was then a shallow sea, at a speed and force capable of blasting a curtain of rock, water, and vaporized debris, an estimated 1.5 kilometers into the sky. When that curtain collapsed back down, it triggered a mega tsunami estimated at around 100 meters tall, roughly the height of a 30-story building, radiating outward across the ancient sea in every direction. Silver Pit now sits in a genuinely exclusive club. Geologists have confidently confirmed only around 33 impact craters anywhere on Earth's ocean floors, the vast majority of the planet's impact history having been erased over time by tectonic activity, erosion, and burial, or simply never found because nobody happened to be running seismic surveys directly over the top of them. Silver Pit only got solved because, by sheer coincidence, it happened to sit beneath one of the most intensively surveyed patches of seafloor in the world. The third discovery doesn't involve life or catastrophe at all, just something that appears to break one of geology's most basic assumptions, that older, denser material generally settles at the bottom, and lighter material generally ends up on top. Researchers working with oil and gas survey data, led by geologist Jan Ruijord at Aker BP alongside Professor Mads Hughes, identified hundreds of enormous underground sand structures scattered across the North Sea, some kilometers wide and reaching depths of up to 200 meters, where that basic rule appears to have been completely flipped upside down. Dense bodies of sand, instead of settling naturally at the bottom of the sediment, stacked the way you'd expect, were found sitting well below layers of much lighter material, made up largely of the compressed remains of ancient microscopic marine organisms, material that should, by every normal rule of sedimentary geology, be sitting comfortably on top of the denser sand, not buried beneath it. The researchers coined two new terms specifically to describe what they were looking at: sinkites, for the dense sand bodies that had somehow sunk downward through the earth, and floatites, for the lighter material that had been displaced upward as a direct result. Their best current explanation is that these structures formed millions of years ago, sometime between the late Miocene and Pliocene epochs, when sudden seismic shocks or dramatic underground pressure changes caused buried sand to briefly liquefy, turning temporarily fluid enough to sink directly downward through natural weaknesses and fractures in the rock, physically displacing the lighter sediment above it and forcing it to rise in its place, like two materials trading positions in a single violent geological event, before everything solidified again exactly where it landed. It's not simply a curiosity either. Understanding exactly how and how often Rock layers can spontaneously scramble themselves like this has real practical stakes, because oil and gas exploration, along with the newer, rapidly growing industry of underground carbon capture and storage, depends entirely on being able to predict where fluids will flow, where they'll get trapped, and where a supposedly solid, reliable rock seal might actually turn out to be sitting in completely the wrong place. To picture the scale of what's actually being described, imagine a layer cake that's supposed to have its densest, heaviest ingredient sitting right at the bottom, only to somehow find that exact ingredient now sitting halfway up, with the lighter sponge underneath it, and no visible sign of how it got there, repeated across an area big enough to cover a small city and buried underwater hundreds of meters deep. That's roughly the scale of the puzzle Rudyard and Huuzi's team is working through. Once they'd identified the pattern in one part of the North Sea, they went back through decades of archived seismic survey data covering other parts of the basin and found the same inverted structures recurring again and again, hundreds of separate syncite and flowtite formations, suggesting whatever process created them wasn't a rare, one-off fluke, but a genuine, if previously unrecognized feature of how sediment can behave under the right violent conditions. That has researchers now wondering how many other sedimentary basins around the world, off the coasts of places like Brazil, West Africa, or the Gulf of Mexico, might be quietly hiding the exact same kind of upside-down geology, simply because nobody has gone looking with the right question in mind. Yet, for an industry planning to bury enormous volumes of captured carbon dioxide deep underground for centuries at a time, hoping it stays exactly where it's put, discovering that entire sections of the North Sea floor have a documented history of spontaneously flipping themselves inside out is the kind of finding that gets read very closely indeed. Line these three discoveries up side by side, and something interesting emerges. Beyond just the individual shouldn't exist headline, each one earned on its own. They represent three totally different kinds of hidden history: a biological one, a violent cosmic one, and a slow geological one, all uncovered within roughly the same 12-month stretch, all sitting beneath the exact same stretch of relatively shallow water. That's not really a coincidence born of the North Sea being unusually strange as seas go. It's much more a reflection of how astonishingly well-studied this particular seabed happens to be. Decades of oil and gas exploration having quietly produced one of the most detailed underground maps of any patch of ocean floor on the planet, largely as a side effect of a fossil fuel industry, looking for something else entirely. Every one of these three discoveries came from re-examining or newly analyzing information already sitting in commercial survey archives, not from some dramatic new deep-sea expedition. The ancient forest was hiding in DNA nobody had thought to sequence yet. The asteroid crater was hiding in rock nobody had managed to physically sample and inspect closely enough. The upside-down sand was hiding in seismic data nobody had looked at with quite the right question in mind. There's also a quieter, more uncomfortable parallel sitting inside the Doggerland story. Specifically, one that connects a drowned prehistoric landscape directly to conversations happening in Britain right now. Doggerland didn't disappear because of any single dramatic event, aside from the Storrega tsunami accelerating parts of the process. It disappeared mostly because sea levels rose gradually over thousands of years as ice sheets melted at the end of the last ice age, slowly swallowing low-lying land that communities had lived on for generations, until eventually there was simply nothing left to stand on. Researchers studying the site have been fairly direct about drawing the comparison to the present day, where global sea levels are rising again, this time driven by modern climate change rather than the end of an ice age, and where low-lying coastal regions around the world, including parts of eastern England not all that far from where Doggerland once stood, face their own slow, gradual encroachment from the sea over the coming decades and centuries. Nobody is suggesting East Anglia is about to vanish overnight the way Doggerland eventually did. But the underlying physical process, ice melting, seas rising, land that was once dry ground slowly becoming uninhabitable, isn't ancient history in the way it might first sound. It's closer to a preview playing out over a dramatically longer timescale. of dynamics that are already underway again. Which raises the obvious, slightly unsettling question hanging over all of it. If the single most intensively mapped seabed on the entire planet was still capable of hiding a temperate ice age forest, a 46-million-year-old asteroid strike, and geology that quietly defies its own basic rules, all discovered within the space of about a year, what's still sitting, completely unnoticed, beneath the much larger stretches of ocean floor that nobody has ever bothered surveying this closely at all? The North Sea didn't get less mysterious the more thoroughly it got mapped. If anything, the opposite happened. The closer scientists looked at ground everyone assumed had already given up every secret it had, the more it turned out to be hiding.